All right, thank you for coming to my talk. I'm Bill Venners. Today I want to talk about async testing in ScalaTest 3.0. And what I wanted to start out with was give you a little bit of something to compare it to. This is the servlet API from Java from back in the 90s. There's a do-get method, and the way you write code that handles web requests is you implement this method. And what you do is you get two things. You get a HTTP servlet request that is a bundle of information about the request, what came up in a get or a post, for example. And then you have an HTTP servlet response, which is basically it's a wrapper for a socket that's directly connected to the client. And what you do in your method is you do whatever you need to do to figure out what to send to the client, and then you send it. And then when you're finished, you close the socket and you return. So essentially, if you need to do something like talk to a database that may take some time, you have to block. So this thread is blocked and can't be used for any other work while that's going on. And that, in the old days, may have made sense, but these days, there's a lot more requests coming in. So that's where reactive style is supposed to help with. So Play, for example, doesn't recommend you do it that way. You can do it that way. But it isn't idiomatic. So here's what it would look like if you did. If you actually did something that took a while and you got a future back, so you have a future integer in this case, what you could do is call await and block the current thread until that future finishes and then return a response. So basically when that method returns an OK to the client, and you know, the response is finished. The request response cycle is finished when the method returns. But if you do that, people will quickly complain and tell you to do it this way, right? What you can do instead is map code that knows how to make a response given the result of the future onto that future and get a new future back that's a future response. So just very quickly, you get a future response back, and then you can return that back to Play. And then Play will put it on a shelf, and then that thread can go do something else. When that future does finally complete, then it will talk to the client, right? So what it does is it makes more efficient use of threads, because threads are a finite resource, and you can handle a lot more clients requests that way than the old servlet way. So the one place that you hear is OK to block is tests, right? That will always be the next thing. It's OK to block in a test. And so here's an example of what that might look like. If I want to test that code, I might call that same method, get the same future back, and then I'll block on it. And then once the integer comes back, so I block the test thread. Once the integer comes back, I do an assertion on it. So that's just done over and over and over, and that's sort of the mantra. That's the idiomatic way to do things. And I was teaching Play a couple years ago, like 2 years ago, and sort of repeating this mantra. And I started wondering, why? Why is it OK to block in your tests? And I got to wondering if that's my fault, right? It's as if the 3 rules of reactive programming are rule number 1, never, ever block. Rule number 2, never, ever block. And rule number 3 is, well, all right, maybe it's OK sometimes to block in your tests, right? So it's wishy-washy. And what I thought was, like, if you can return a future response to a web framework, why can't you return a future assertion to a test framework, right? So it would look like kind of like the Play code. I, in my test, call a method that gives me back a future int, and instead of blocking on it and then doing an assertion, I just map an assertion onto that future int and get a future assertion that I return to the test framework, right? So that was my idea. I thought, well, that's mildly interesting. I wonder if that would be interesting to other people. So I talked to some reactive folks, the Akka team, Heiko Seeberger, I think, was in that email series of emails to get their reaction to this idea. And they all kind of liked it. They kind of said, yeah, it's kind of interesting. I think that'd be useful, but I didn't get this, oh my God, that's fantastic, I need that, right? I didn't get the vibe that this was really a burning need. And I try very hard not to just toss stuff that pops into my head into the library because it's already big, and it just, if I don't be very, very careful about what I put in, then it'll just explode in size, right? So I wasn't planning to put it in until this happened. Sorry, Sebastian. Essentially, we decided, yes, that guy, we decided to port ScalaTest to Scala.js because a lot of users wanted it, and we thought it would be pretty easy. It took over a year, and it turned into a really huge yak shave. So one aspect of that yak shave, a pretty significant one, involved async testing. And what I learned, and we were Java people, so we weren't so sophisticated about JavaScript. But it turns out that in JavaScript you can't block because there's one thread, essentially, going around in a circle inside the JavaScript VM. And it just, each time it comes around this part, it picks up a job to do out of a job queue, and then it does that job, and then it picks up another job and does that job. That's what it does. That's what JavaScript does. It doesn't ever get bored. It just keeps doing that. But because there's only one thread, you can't block. So I didn't quite understand what that meant until this user submitted this bug, this issue on GitHub. His name is Chandra Sekar Code. And what he wrote was this test that calls into sample service.getData, which gets an X is a future of, I forget, future something. So future value in ScalaTest is kind of a DSL for a wait, but it throws, basically it will block that future for a period of time, and if it times out, then you get a test failed exception with a nice stack depth so you know where the line of code failed was, right? And a nice error message. But if it does complete before the timeout, it just returns it, and then you can do further assertions on it, right? So on JVM, that worked fine, but on JavaScript, basically we were trying to block in JavaScript, and the way we ported that to JavaScript was we just didn't block. And there is certain execution context in JavaScript where it works fine. But the one he was using, none of them worked for him because it turned out that you can't actually do things with multiple threads in JavaScript. And what his sample service.getData method does, it calls outside of the VM. So it's a method inside JavaScript that goes outside of JavaScript. And now you're in, and like if you're on Node, it's a C code, which has access to other threads. And it can kick off a thread over here in C. Now you've got two threads. You've got the JavaScript thread and the C thread going. And meanwhile, the JavaScript thread says, OK, I've got back a future. I'm going to go do my next thing. And this thing's over here doing its thing. And that's not easy to do. But and then eventually this finishes, and it sticks a job on the queue that the JavaScript guy will come and complete the future, right? And when I saw that, that's when I realized, oh, the only way I can get that to work is async tests, right? So this was the burning need. Either we didn't port ScalaTest to Scala.js, or we added async testing support to ScalaTest. It was one of those two choices. So basically what I wanted to do was kind of give you a little bit of background and talk about like what we had to work with to get async testing in. In ScalaTest 2.0, we added this ADT called outcome that represents the outcome of a test, and there's 4 possibilities. A test can either succeed, fail, be canceled, or be pending, right? And succeeded and pending are singletons. They're singleton objects. They're just, that's it. It either succeeded or it's pending. And failed and canceled wrap an exception. Canceled always wraps test canceled exception. And failed can wrap test failed exception or any other exception, because any other exception will cause the test to fail. And so that existed. And then we had a method called withFixture in Suite from 1.0. But in 2.0, we adjusted its signature to have a test function that returns an outcome. So what's passed to withFixture is a function that represents the body of code of the test. And when you execute it, you don't have to pass anything into it. It will give you back if this test either succeeded, it failed with an exception, it was test canceled exception, or it canceled or was pending, right? And then withFixture itself returns an outcome. And what you can do is things like shown on the second example. You can override withFixture in your test to do setup and teardown in one method. You do some setup, and then you, in a try block, execute the test function. And then in a finally clause, you do the cleanup. So if the test function happens to blow up with an exception, which it shouldn't, but if it does, it will still do the cleanup, right? Otherwise, when the test function returns, you've got an outcome, you do your cleanup, and then you return the same outcome. So the default implementation of withFixture is just invoke the test function, right? So to make these stackable, what I recommend people do is actually not invoke the test function directly like that, but to do this, which is to delegate invoking the test function to a super trait with fixture. And eventually, you can stack them, and eventually you'll bubble back up to the one in suite, and it will execute it, right? So that was 2.0. So there's a lot of code doing that. And then most people just do that in their test class. But if you have several test classes that are, you're repeating the same with fixture code over and over, then you can factor it out into a trait that you mix into those test classes. So sometimes people will make a mix-in trait like this. This is how I recommended people do it, which is you extend suite mix-in, which is a trait that just has abstract lifecycle methods. So it has an abstract with fixture, just the signature, no body. And then you say my self type is suite, so I can only be mixed into a suite, which will have that one that its default implementation is just invoke the test function. And then you just abstract override with fixture, and you can mix that into any test, and you have several of these, you can mix them together, right? So that didn't happen as often as people just doing it together, but these are the things that we had. Basically, users can define with fixture methods and did, and they can compose them by stacking traits, which sometimes they did. But what was the problem, or the impedance mismatch for async, is that just like that do-get method in servlet, the type, the signature of the test function and with fixture means that the test has already completed once the test function returns and once fixture returns, because it's already returning an outcome. So you have to know it's succeeded, canceled, pending, or failed. But if you're doing an async test, you're returning a future assertion. We don't know what the outcome is yet, right? So one of the first things I had to figure out was future of what, right? When you map an assert onto a future int, you get a future of any, future of unit. So I wanted to be able to say, just like you can say, you map a response onto a future int, you get a future response that you can pass back to the web framework. I wanted to say you get a future assertion that you pass back to the test framework. So I wanted something named assertion. And it took me a few iterations to figure out what it was, but it's actually Java, a Java interface, unless it's on JavaScript, but in which case it's just a trait with nothing in it. But it's just a marker trait. And then I did make a type alias, because I wanted something called ScalaTest assertion. So that is just a type alias for the more longer name, ScalaTest compatible assertion. And the idea there is that now that this needs to show up at the end of a test, if third-party libraries can't easily be or give an assertion, then it's clunky, right? So what we're planning to do, we haven't done it yet actually, is take the Java interface assertion and release that as a Java jar that doesn't have the underscore Scala version number. It just has that in it, and that's easy to make a dependency to third-party libraries that want to add things, right? So they can be a ScalaTest assertion without actually depending on a version of ScalaTest. And then we took and added a super trait to succeeded, which was already existing, and made succeeded an assertion. So then what we did with all of our matchers and assertions is we made them into, basically in 2.0, this had type unit and returned the unit value. So we changed it to have type assertion and return succeeded. So in the old days, it returned the unit singleton. Now it returns the succeeded singleton. But no code should really be affected by that. And if it fails, it does the same thing it did before. It throws the same exception as before. So all the old behavior is the same. But the singleton that's returned when it succeeds is now succeeded and instead of unit. OK. And then we did the same thing for matchers. X should equal 1. Gives you the type of the expression is assertion. The value is succeeded. And if I change 2, I get the same exception I did before, right? OK. So now that's what the type of assert is. So if you map that on, you actually will get a future square brackets assertion. OK. And then what you can therefore do is this. So this is how code, Mr. Code, who submitted that issue, could rewrite his code. to get it to work is instead of extending fun suite, he extends async fun suite. And because of the width fixture impedance mismatch, and because you got all this old code, partly because of all the old code, it made it impossible to do something, bring it together. But it's also just simpler, I think. If you don't need to work in future space, it's simpler to have something like fun suite and a test function that returns an outcome. We made async variants of all the existing style traits. So off to the side, there's new ones. So there's an async fun suite now. And in there, what the type of the test is future assertion. You need to give it a future assertion. So given his future int that was truly async on JavaScript, he can now just map his assertion onto it and get a future assertion back. He passes that back to ScalaTest, and ScalaTest puts it on the shelf. Basically, it doesn't put it on the shelf. It registers callbacks, right? So that when that completes, events go to the reporter, test succeeded, test failed, etc. Right? And then we added an implicit conversion from assertion to future assertion so that you could have tests that end in assertion, so they're actually not async, mixed in with tests that end in a future assertion. Because sometimes you'll have like half your tests you want to have mapping futures and the other half are just normal. Right? So that's how we put it in. And I wanted to show you a couple, just to give you an idea of like how much of a change this was for us. I mean, for your code, it should be pretty easy to upgrade, but there's something called inspectors in ScalaTest. I can give you an example. X is equals list 1, 2, 3. If you import inspectors, dot underscore, I can say for all x's, given an x, x should be greater than 1. I'm sorry, 0. I would have failed that test. So these are returns succeeded, too, because that could, like, it's an assertion, really. So that kind of would make sense. The problem is if you had done something like this in existing code, it would break, and it'd be very actually annoying to have all that broken code, and I want it to be easy to upgrade. So we had to add complexity to the signature by adding more implicits. There's another type class that infers the type here inside this function. And if it's type assertion, then the for all results in type assertion. Otherwise, if it's something else, it doesn't have to be unit. It could be anything. It could be an int. Now the type of for all is unit, which is what it was before. Right? So the difference, here's what it was in 2.0, this signature. And the collecting is like ad hoc polymorphisms, but it's a type class that allows this to work on things for which it makes sense and not compile on things for which it does not make sense. But in 3, look at what happened to it. It's got another thing called inspector asserting that is another type class that says it'll actually work for anything because that means all the old code works. But if the type of that thing is assertion, the result, which is a dependent type, is going to be assertion. Right? So that was forced on us by this. It was really a big change. And there's 2 other things just parenthetically I want to mention. We had to add position to a lot of things. So a lot of the difficulty of supporting Scala.js had nothing to do with Sebastian. It wasn't his fault. It didn't have anything to do with JavaScript. It had to do with I didn't see this coming, so I did a lot of things that made sense on the JVM that don't work on JavaScript. So I had to untie a ScalaTest from the JVM. So an example was the way, like if you get a test failure, there's this little link that says the file name and the line number where the exact assertion was that failed. We did that historically by looking on the stack and just saying, oh, there it is, it's that one, so we put it in the information that the IDE can use. And that works fine on Java, but it just isn't practical on JavaScript. It just doesn't work. So what we had to replace it with was this thing called a position, which is passed in implicitly. And if there isn't one in scope, there's a default one in the companion object that uses a macro to ask the compiler, hey, where is this line of code? And that actually worked great, but it was an enormous amount of work. So that's in a lot of places. Anywhere where we needed to say this is where the failure was, we had to add that. And then we also, since we added another implicit, we went ahead and passed in a prettifier. A prettifier is just a way to change the toString of a type. So that's also being passed in there. But you can see how, I mean, really this whole exercise was a real struggle to add this feature people wanted, which was what they wanted is a full-featured test framework that worked both on the JVM and on JavaScript. Without exploding complexity. That was a real, that was really hard. Okay, so that's inspectors. So now this problem still, I haven't shown you what we did with. So this just doesn't work for async because the type of this function and the type of the with fixture method, just like do get, it says that the test is finished when these things return. So what we ended up doing was there's very few breaking changes in 3.0, but there's 5, and I'll just go over them quickly at the end. This one, what I did is I took the with fixture method out of suite, and I moved it down into something new called test suite. So what test suite represents is the level of abstraction of suite where the test function is defined, where the type of the test function is defined. So for the traditional styles, that's test suite, and it looked like it did before. It's just the same as was in suite before. But then we created this one called async test suite, which is, all the async styles are below that. And instead of that type being outcome, it's called future outcome. And a future outcome, all one word, is just a wrapper object for future square brackets outcome. So it is inside a future square brackets outcome. But the problem with it was, let me just show you in Scala doc here. The problem with initially it was future outcome with square brackets. But in futures, like the result of a future is modeled with a try, and a try is either a success or a failure, right? So it means a future outcome could be a success failed, or a success succeeded, but it can't be a failed, right? It's just I thought it'd be very confusing for users. That was one problem. And the other problem is in production code, you actually want something different than in test code. And to make things consistent, there were some things that were quite clunky with future, and I'll show you an example in a sec, but what future outcome gives you is just the methods that make sense for transforming future outcomes with consistent naming that matches testing. A lot of it is registering callbacks, right? And you can use these in your with fixture method that takes future outcome because you will transform them that way. And the breaking change is that those old traits that you factored out common with fixture methods will break because they say they extend suite mixin and they're abstract overriding with fixture and it's not there anymore. Right? I moved it down to test suite and test suite mixin. So all you have to do to fix it is that will just not compile, and you go and you put the word, the bold test, you just put that in front of those two places and it's the same. So I think that should be, that'll affect some people, but should be pretty quick. And then another problem was like coming back to this is, let me go back to that one. The one where I had a try finally. This one's easier to see. So try, test, finally, cleanup. If you do that in a async with fixture, when you say try test, it returns a future outcome. So the test hasn't actually finished yet. So now your finally block is going to be executed, and it will do the cleanup too soon. Right, so you can't use try finally with an async. Well, with a future, it doesn't work. It does the cleanup too soon. So I came up with a new syntax called complete lastly, which is like try finally for futuristic things. So that looks like this. So you just say complete, and then in there you have to have some code that produces something that's futuristic. So there's a new type class called futuristic, which I thought was cool, because I wanted it to work for future of any type T or future outcome. So that I needed to be, I had to create a type class for it. And what it will do is, if that blows up with an exception, lastly works just like finally. It just executes the cleanup right then and there before the thing is propagated, the exception. But if it doesn't throw an exception, it means you got some futuristic thing back. It just registers that cleanup code to be executed after the future completes and returns a new future that doesn't complete until both the original feature completes and the cleanup has finished. And if the cleanup blows up with an exception, it actually fails with that exception. So that's an example of something that you can do with future square brackets outcome, but it would actually take 2 method calls. So it's actually quite clunky. But in future outcome, the new type that we created, it's just 1 method call. So that's complete lastly. And then another thing that was kind of an impedance mismatch, now that we need a type at the end of a test called assertion, was intercept is used a lot by people. And what intercept does is ensure that a bit of code throws an expected exception. And then it returns that exception so that in case you want to inspect it further, saying this exception, not only is it a string index out of bounds exception, but its error message starts with this word or something. That worked fine, except it doesn't have type assertion. It actually has type. I can't change that to be type assertion because it has the type of the exception you put in square brackets, the expected exception. So I added a new thing called assert throws, which does the same thing as intercept, except it returns type assertion. So going forward, the recommended style is always use assert throws unless you actually need to do an assertion on the exception that is caught, and then use intercept. Because you do the intercept, you grab the expected exception, then you do an assert, and now you have an assertion, right? OK, but that doesn't work in async. So imagine this first line of code. I can't say future map and then this value coming in somehow assert throws, because first of all, if the future fails, the function passed a map doesn't get executed. It just passed, the result of the future that comes back from the map call, it just gets the same failure as the original future. So that wouldn't work. And then the second one doesn't make any sense either, because the future inside assert throws doesn't actually throw anything. It just fails with an exception. It doesn't throw it, right? So in the future API, that is called, the concept of like expecting an exception and recovering from it is called recover. So I named these two methods recover2. And they're like, the first one is like intercept for async, intercept for futures. Recover to exception if illegal state exception. This thing takes a future or futuristic thing inside. If that fails with illegal state exception, that's expected. It will actually transform that future into a future illegal state exception. It'll actually be in there, because then you can do an assertion on that. You can map an assertion on that saying, oh, and that illegal state exception's error message should start with something, and now you've got a future assertion, right? So that's like intercept, but in future space. And the one down here, recover to succeeded if, is just saying all I care about is that it throws that. I don't want to look at it anymore. So that could be an assertion that ends a test, because what it changes the future of whatever to is a future assertion. OK, so that's two more things we had to invent. And then lastly, what I would like to kind of give you as a puzzler, there's another, this one, like a design question that was really hard. And I'm not sure I got it right, but I'm going to give you a hint, which is that ScalaTest 3.0 has something called the serial execution context, but I won't tell you what that is. So the puzzler is actually this person's, it was submitted as an issue for ScalaTest 3.0 RC1 or 2. I mean, it's a very recent issue. And I did change something for this, but I don't actually think it's a bug. It's intended behavior. So his code is a little bit, I think it'll be easier to, less hard to, it'll be less of a puzzler if I show you in a different way. So I did change one thing. But this code actually works fine on the JVM, but it doesn't work on JavaScript. It threw that index out of bounds exception, and now what it'll throw is a not allowed exception with a better hint as to what the problem is. But what he did is he has this getNum method that has a hard-coded execution context, which is called global. So on the JVM, global means a thread pool. On JavaScript, it's the queue one. It means put it in the queue. And I'm just looking at Sebastian to make sure I'm not lying. OK, I don't think I'm lying. So, and inside ScalaTest, in an earlier version, I thought, geez, I have no idea what execution context people are going to want to use, so I'm just going to make them say one. Right, so it wouldn't compile it. And this used to not compile the lower code there, because it doesn't have an execution context. But I added a default one. And it's called serial execution context. So I'll explain it in a bit. But so there's a default one just to get rid of boilerplate code. And if you want to change it, what you do is this. You just say override. Basically, it's called execution context. This is something inherited by any async style trait. You have this. And you can override it and change it. So on JavaScript, maybe I'll make it the run now execution context. On the JVM, maybe I make it global, whatever. Right? So the puzzler is, what I told him is, I think it's your bug, not my bug, kind of. I mean, maybe it isn't, but there's like a code style, questionable style here. So I noticed last talk, Holden said he'd give away a free book. So I'm going to give away this free book to whoever answers first. But no, actually, it can't be first. No, it is first. You don't have to even be correct. You just have to be brave. Does anybody, basically the question, the puzzler is, yeah, you can. Should be future.successful. I think in life that's true, but I'm not sure about future. Oh, actually, not only that's actually that is true. I never thought of saying it that way. You get the free book, awesome, but you can come up and get it. Otherwise, you might look like every other red shirt around here. I'll come. Hey, I can walk around. Why did you say that it should be future.successful? Yeah, maybe you can tell. Yeah.
Future.successful doesn't need an execution context.
Correct. Yep.
So I thought, well, that's probably.
Yeah, that would have solved the problem, actually. But this was kind of, I think, what he had shown here. Yeah, thanks. What he had shown here was kind of contrived code to demo the problem in ScalaTest, what he thought, in the release candidate. And in his real code, he probably let's assume he does need an execution context. So what would he do differently? Yes, Sebastian. Exactly, that's what I think. So it means the same. It's the same problem, right? But the way you solved it is just said, don't take an execution context here. So what isn't seen here is, behind the scenes, the future.apply factory method does take an execution context, and so it's going to bring in that implicit global one, which on JavaScript is the Q one. But getNum doesn't pass one in. So when you call getNum, it's basically hard-coded. This is like static cling, right? It's hard-coded to one execution context, which is usually a bad idea because you can't, like if you do that all over the place and you need to change it, you'd have to go all over the place and change the hard-coded things. You normally want to pass it down. Then you can configure it. So I think and if he did that, then down here where he called getNum, it would pick up ScalaTest's serial execution context and everything would work fine. Right? So I think it did find a bug, but on the JVM it doesn't find a bug because in the JVM it works. And the way it works is kind of weird because of like that mantra of never ever block. On a web server, I think that makes sense to make maximum use of threads. But when you're running a test, if you have like 1 million tests running at once, that may not be, I mean, you're making maximum use of threads, but all your tests will time out because nobody can get anything done. So what we do is, the way the serial execution context works is when you do a map and the execution context is used, it doesn't actually execute it, it just remembers it. It just says, okay, at some point later I have to do this task. And it just keeps track of all those, and you get this job queue. And then when the test body exits, you've got a future assertion. And what ScalaTest will do internally is say, was this execution context used? Was our internal serial execution context used? And if so, it uses the same thread to execute those things. And then if there are other threads involved on the JVM, what we do internally is block, which is kind of, you never do that in a web server, but in the test, actually, it makes sense because that's how you can throttle how many tests are running, is by how many threads you have going, right? So anyway, that was just another example of how, some of the challenges. And then before, that was a little foreshadowing, unintentional. But before I go to Q&A, I just wanted to quickly go through the breaking changes. One of them is that good and bad in Scalactic. So Scalactic is a smaller library that are things people ask for in ScalaTest, but they also want to use in their production code. And so they're always released together, and they have the same version number, so that's how you know what's compatible. And so good and bad had 2 type parameters, and one of them was unnecessary, so I just removed it. So that will break little or no code, I think, because most times people don't say those type parameters. It works the same. It's just the one that wasn't needed is gone. Because we started using prettifier, prettifier did exist before, but now we're passing it in as an implicit. And in the old days, this is you'll be thankful I did this. In the old days, it extended any to string. It was like a function 1 any to string. So by using it implicitly, now you've got an implicit any to string, which is like one of the most evil things I could do. So I severed that, but that will likely break no code because no one was using it as a function. Pretty methods we also changed to just take an implicit prettifier. That should break very little code because most people didn't use it, and it's very easy to fix. This time-limited test, though, basically there's something called timeouts that was very JVM specific. It used something called interrupter, which the default implementation was to interrupt a thread. That doesn't work on JavaScript. So we changed something to time. We made something called time limits, and it has something called signaler, and its default is to not do anything. The other thing that's hard to interrupt is futures. You just can't. There's no API in futures to change, like say stop doing what you're doing. So timeout still works the same, but now timeouts and interrupters are deprecated. So you'll have a year or 2 to like transform it over to time limits, and that's pretty straightforward. But it's not. You don't have to do it right away to upgrade. But time-limited tests, it was just I kind of needed to change that to use time limits. So that one, people using time-limited tests will have to change before they upgrade from timeouts to time limits. From interrupter to signaler. So. And then there's this one that I already mentioned where you have to put the word test in front of sweetmix and sweet. That should be pretty straightforward. And the last one is mostly ScalaTest itself and tools vendors. There's something called when completed on status, which users don't usually use. And it used to take a Boolean to unit. And status was async before, but it was just used for making sure after code and after all happened after parallel tests finished, right? And it turned out we had to make that a try because there were now situations where you could end up with an exception that should cause the run to fail, but in a different thread, right? So that shouldn't really affect anybody, and that's it. So I think upgrading should be easy, and I'm back, baby. What's been happening? Last night I had maybe too many wines, and I was tricked into promising that I would show David Hasselhoff. So. That's my only explanation, but I do keep my promises. I don't think that's his real Twitter account because he's not that young anymore, and I think it's like making fun of him, but I thought that was funny. And I think if those cheat sheets got passed out, I just had 50 leftovers from New York, and I thought I'd give them to you guys. They just have like some of the new things on there. Those of you that got the cheat sheets, I hope you like them. And then I will take questions. I probably have 5 minutes or so. Yeah, I have 7 minutes for questions. Please come up to the mic, yeah.
Hi.
Hi.
So for the, for the futures, for the before a test with fixture, is there any way to get the setup into a future as well?
I'm not sure I understood the question. Let me go back to can you repeat the question?
So,
is there a slide
with fixture in the second part there, okay?
Yeah.
The complete and the lastly are implicitly futures, but what about the setup as well?
Oh, maybe talking to the mic. It might be directional. Yeah.
Sorry.
There you go. That's better.
Oh, right. Okay. Sorry. For the with fixture.
Yeah. For the with fixture.
The complete and the lastly return the future outcome.
Correct.
But the setup. What happens with the setup? Is there any way of forcing a setup to be in the future as well?
If you set up in the future. No one ever asked for that, so you'd have to do that yourself. Basically, I'll have to think about that. Oh, well, let's talk after. But that never occurred to me in the past. Any other question? Yes. Hey. Oh yeah, complete lastly is unless I misrecognize you. Never mind. Please go ahead.
So one related problem or notion to the asynchronous testing is the idea of virtual time. So imagine if you test something that code with delays or retries, like retry after retry 10 times after 1 second waiting. So if you test this like with real time, the test will take 10 seconds. But some systems, they introduce this virtual time. And do you have any plans for ScalaTest to have something like this?
I haven't heard that request either. So that's the question was about virtual time, which is interesting. But we don't have anything currently, and I don't have any plans either. But not. I'm curious. I mean, you can come talk to me after. Be interested in that, hearing about what that is. Anybody else? Boy, I need more free books. I'll tell you what. If you ask a question, you can get a copy of that down at the Code-Centric booth for free. Sorry. I tricked you. But it's a nice magazine. Anyone else? Ah, good.
I think you said that complete lastly, that the complete block accepts a return type of any futuristic, but with fixture is set to return a future outcome. How do you turn the futuristic into a future outcome?
Well, I can show you futuristic, but basically, you usually, well, let's just go look at it. I'll show you futuristic. Oh, no, that's not it. That's this guy. Future. There's futuristic. It's just a type class. It says futuristic of T. And I pass in, basically, I pass in the futuristic. I pass in the cleanup method, and I get back the same thing. So if it's a future int, I get back a future int. If it's a future outcome, one of these things, I get back a future outcome. So.
Okay, so how does the complete lastly block inside with fixture know what future outcome to return? Because if you produced a future instead of a future outcome, then it would be a futuristic, and complete lastly would work, but.
Yeah, so what basically complete lastly does is there's implementations of futuristic for square brackets future of anything and for future outcome. And the with cleanup method of that instance of futuristic will take the futuristic thing. So let's say it's a future outcome. It takes it. It attaches the cleanup code, which was passed to lastly.
I get that. I don't think I'm making my question clear. I'll come talk to you later.
Okay, sure. You can talk to me in the future. All right, I have a few more minutes if there's another question. Anybody? All right, I don't see any hands. Oh, yes, there is one. Hello.
How do you deal with timeouts?
Oh, yeah, timeouts is a good, that's a funny question. So I thought I was done several different periods, like, okay, we finally finished this yak shave. And Heiko Seeberger asked that question, and I was like, oh. So there wasn't one, but now that's what time limits does. There was a way before to do it called timeouts, and it's the same syntax. So time limits is the new one, but what's different about it, it was fail after and cancel after. So the methods are the same, but now with time limits, it does something different if that's a future, or futuristic probably, right? It does, if it's anything not a future, it just does the old behavior, which that code has to finish within that amount of time.
Yeah.
And it works on JavaScript or Java JVM. But if it's a future, it's the future has to complete in that amount of time, and it returns a future. Okay. So that's time limits. Timeouts was just the first thing. Yeah.
Thanks.
And then you're welcome. And then time-limited tests. If you just want your tests to have a timeout, then you mix in time-limited tests, and it uses this fail after. So. Anyone else? Okay, I think I'm competing with potential beer, probably. So, all right. If there's no other questions, I would like to say thank you very much for coming, and thanks for using ScalaTest.